Okay, class. So we are looking at 6.6 medians and altitudes for triangles. And this section is actually something that is not as difficult as you may think. However, it really incorporates a lot of information we have learned in the past and basically applying it into a new concept. And so before we do that, let's go ahead and look at this dude first. And so here we're trying to find the length and we're trying to find the midpoint of the segment GH. So length, of course, is going to be our distance. Midpoint is, well, our midpoint. And the segment GH is already graphed for us. We'll just assume that we're actually perfectly on these lines. I know it looks a little bit off, but we'll just assume we're perfectly on those whole numbers. And so if we look at these, and let's go ahead and decipher, well, which one do we want to do? We want to do length first? Do we want to do midpoint first? I think midpoint would probably be easier. So we'll take our midpoint. Midpoint, of course, is x1 plus x2 divided by 2, y1 plus y2 over 2. We're going to take the x values and add them. So g has an x value of 4. 4 plus -3 for our h divided by 2. y1 for g is going to be -3 plus our y2 for h is going to be 1 divided by 2. And then we are just going to add and divide. 1/2. -3 plus 1 is -2. -2 divided by 2 is going to be that -1/2. And so our midpoint is going to be 1/2 comma -1. So we'll go ahead and label that M for our midpoint. And then for our distance, we're going to use either two methods. You can use the distance formula, or you can use Pythagorean theorem. Okay, the way we're going to use Pythagorean theorem is we're going to create a right triangle with the two endpoints that we currently have, HG. And so in doing so, because we made our triangle like this, that makes this angle 90 degrees. And we can actually just count the sides and then figure out our hypotenuse from there. So from H to our right angle, it's 1, 2, 3, 4 units. From our right angle to our G, it's 1, 2, 3, 4, 5, 6, 7 units. And then we're going to use Pythagorean theorem. Of course, 4 and 7 are going to be our legs, our A and B. So 4 squared plus 7 squared equals C squared. But of course, the C squared is actually the length of HG. We'll solve. 4 squared is going to be 16. And 7 squared is going to be 49 equals C squared. Add them together, we're going to get C squared equals 65. We're going to get a final value of C equals the square root of 65. And there's no real need to simplify it down into a decimal because it does not ask for a decimal. So we can just leave it as the square root of 65. Okay. We're actually going to skip the exploration, at least as far as me doing the entire thing, but I will write it in the answers as appropriate. So B should be midpoint of 0, -3, but that looking at the actual problem, it says that's point D. So really it's D 0, -3. Part D, we can say that AD is congruent with BD. And that's because D is midpoint of AB. Determine the slope of BC. We said the slope M was -3. Then the slope of the line perpendicular to BC is 1/3, the opposite reciprocal. And then the equation that we can write for this is going to be y equals 1/3 x minus 3, if you want to put it into that slope intercept form. But if you're going to go through the point A and put it into point slope form, we're going to have y minus a -4, will just change to a double negative, be a +4 right here. Then we'll have the slope that we just got, 1/3 times x minus a -3, but because double negative, add to a +3. Okay, just to be very clear, that's not supposed to be an alpha, that's supposed to be an x. Just like so. And we do not have a part H, I took that out. On ahead. If you missed our key points, we're going to have a median of a triangle is a segment from a vertex of a triangle to the middle midpoint of the opposite side. And the way I'd like to describe this is, instead of kind of trying to memorize this whole blurb, when we think of median, I want us to think angle, arrow, meaning 2, angle to midpoint. And I think that just makes a lot of sense for us. So if we look on the diagram on the right-hand side, we're starting at this angle and we're going to this midpoint. So the line in between the two of them, that's being highlighted, is our median. That is what we call our median. So go ahead and write that in. Median. And the thing is that for every single triangle, no matter what, every single triangle is going to have 3 medians. Don't overthink that part. So if we were to label this triangle, let's say we labeled it, let's do a different color, using a lot of blue right now. A, B, and C. Let's start with angle. Let's start with angle A. Angle A must go to the opposite side of itself. So looking at this diagram here, this figure, the opposite side to angle A is going to be away from angle A. So we're going in that direction, which means that side BC must be the opposite side. And so if we're going to erase this a little bit, we start at A, we go to BC. There it goes. Like so. And that's our median. But because we know that this point in between B and C is the midpoint, we know that these are congruent as well. Next, if we look at B, angle B has a median. We have to find the opposite side. We only have A and B and A and C left as our options. Well, A and B doesn't really make sense. So it only makes sense to say that A and C must be the median. And of course, I'm not entirely measuring out exactly what the median is, but the understood idea is that this is about where the median is, and we know that this is going to be congruent for both of those segments. Last but not least, that third one, angle C goes to AB as its opposite side. Because that's the opposite side and the point in between A and B is the midpoint, we know that these two are going to be congruent. And so we get this nice looking Skittles triangle here. Okay. The next key point goes over what we call the altitude. So the altitude of a triangle is the perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. And so much like the previous theorem or the previous key point we saw, we're going to reduce this sentence or reduce this paragraph down. Actually, no, it is a sentence. It's just one really long sentence. And so we're going to reduce this down, make it into something we can actually understand. So it says from a vertex to the opposite side that is perpendicular to, that is a perpendicular segment from that vertex. So we're going to rewrite it as angle goes to, with that arrow, perpendicular segment. And actually, if I'm really thinking about it, I'm thinking you might even also need to add opposites perpendicular segment, meaning opposite side perpendicular segment. But you know what? We'll even add that opposite side. That might be even easier to understand. So angle to opposite side perpendicular segment. Mouthful, but it contains everything that we need to. And so if we look at the diagram on the right-hand side, we'll see that there's two examples. We have this example, and we have this example. They're both correct. So what this is telling us is that these can either be inside the triangle or they can be outside the triangle. Now, for some of these, it's going to make a little bit more sense to say that they're going to be on the outside rather than inside, and vice versa. So if we look at this diagram at the very bottom here, this triangle that we have, and it labeled the triangle just like how we did beforehand. So angle A, angle B, and angle C. We look here, the immediate first angle that should be easy is going to be B. And remember, we're going to go from B to the opposite side perpendicular segment. So opposite side for us is AC. And we have to make a perpendicular angle with AC. Of course, we can't really measure everything out, not with a protractor at least, but we can estimate pretty darn well. We'll say that's 90 degrees. And that's our altitude. But going back to the question that we have here in our turn talk, it says how many altitudes are there for every triangle? And that's actually really simple. Don't overthink it. You still only have 3 altitudes. But now we get into A here, and it's really hard to tell. You can turn your head around, you can turn your paper around. It's hard to tell. Maybe B, maybe A to B, that's our perpendicular segment, but we don't know. It's hard to tell. But the idea is that we should know that it could lie inside or it could lie outside. So let's just go ahead and think inside, just for argument's sake. We'll just say that is the altitude. But we should know that there are going to be 3 altitudes. And we'll do the exact same thing with C. We don't know entirely if it should be inside, but at the very least, we know that they're going to exist. And then one other quick thing I wanted to add about median is what we should notice here is that we have an intersection right there. So the 3 medians will intersect. Oops. Will intersect. Looking for backspace. There's no backspace. Will intersect. There we go. And those are our 2 key points for the day. Nothing too hard. So we have example 1 here. We have QT is the median. So this line right here is the median, which makes T our midpoint. Then we have RT, which is this line, is 5x minus 12. Then we have TS, which is this segment, 3x plus 6. And we have to determine RT, TS, and RS. Okay, and so just like the previous lesson, I want to kind of rationalize this. And so what this is saying is that since QT, segment QT, is the median, it follows that RT is equal to TS, which, because they are equal to each other, they are by definition also congruent. And we can put them equal to each other and solve for x. So 5x minus 12 equals 3x plus 6. Add the 12 on both sides. Subtract 3 on both sides. 3x. Get 2x equals 18. Divide by 2. Get x equals 9. Now, of course, some of us might think, oh, we got to stop here. And that's not the case. We're looking for RT, TS, and RS, not specifically just for x. But it says RT, TS, and RS as 3 different values. In reality, we're only looking for 2 values. Because we've already said RT and TS are equal to each other, then we only have to solve for one of them. And we've already found both of them. So we'll solve for TS because I think it's the easier of the 2 expressions. TS equals 3 times 9 plus 6. You do the multiplication and add, you're going to get 33, which means that RS is going to be, or sorry, RT is going to be 33, which then means that RS will equal 66. And that's it. That's our problem. Right along. What I suggest is pausing the video and working on this example for yourself to see if you can get the answer correct. If not, you can always ask me questions at an appropriate time. But here we're going to determine the area of the triangle using the altitude KS. Let's remind ourselves of a couple things. Area of a triangle is area A equals 1/2 times B times H, where B is the base and H is the height. Additionally, that altitude, we're going from angle to opposite side perpendicular segment. Like so. So first, let's establish which one is our angle and which one is the side part. So looking at KS, K is our vertex, that's the angle, and we're going to S, that is our perpendicular segment, because PN is our opposite side from K. And so in order to actually solve this problem, we have to do a couple things. Okay, first, remind ourselves, this is the altitude. So we'll write that in, altitude. But we need to know the height and the base of our area in order to figure out, well, what is my area? And so there's 2 ways you can go about this. The first way is solve for your base first, which I don't recommend. Just do that as the last. What I do recommend is solve for your height. Your height is going to be the altitude. Okay? The height is going to be your altitude. That's how you're going to find your height. And so if we look at this triangle KSN, because we know that this is an altitude and we know that this angle must be perpendicular, must be 90 degrees, we can use Pythagorean theorem. So we're going to do just that. We're going to treat this value for our SN as our A, and we're going to treat KS as our B, and of course, since 10 is the hypotenuse, that's going to be our C. So we're going to take 4 squared plus B squared equals 10 squared. And we're going to solve. 16 plus B squared equals 100. B squared equals 84 because 100 minus 16. And then B is going to be the square root of 84. Now, I would just leave it like this, just for right now, until we actually put it into our area equation. So that is a perfectly fine answer for right now. Then we found our height. We had to find our base. Now, something that we may not recognize or remember from previous times we ever did area of a triangle is that the base of the triangle is the entire base. Okay, the entire bottom. So if altitude is my height, my base is going to be the entire opposite side from K. So this is our base, not 4, not 7, but 4 plus 7. So the base as a whole, Pn, is equal to 11. So it's not a hard thing to miss, but it is a mistake I can see happening. Now, by technicality, you could take the area of both of the smaller triangles, but there's really no need. Really just do all in one fell swoop. So after you've done all that, we're going to find our area is going to be 1/2 times 11 times the square root of 84, plugging in all of our values, our base and our height. And once you multiply all of that through correctly, you're going to get a value of 50.408. Remember, we round to 3 decimal places. But because you're working with an area question or really any other question that has a unit, you want to make sure you're writing your units. So this is units, and because it's area, unit squared. Okay. Example 2. Here we have to determine the coordinate points of the median NK. Remind ourselves, this is a angle to midpoint kind of line. Looking at our diagram, we are starting from point N, and that must mean that K is midpoint of the opposite side to N, which the opposite side to N is of ON. So K is the midpoint of ON. So we have to find the midpoint. Taking these values of O and M. O is -5, 1. M is 4, 3. Using our midpoint formula, -5 plus 4 over 2, 1 plus 3 over 2. Simplify that down all the way, and we are going to get -1/2, 2. So K is this value right there. Okay. We know it's a median, so we can go ahead and connect those lines. Okay. Then we have to find the equation of the line that contains the median. And we can do this 2 ways. We still have to find the slope. So that would be the first thing we have to do. But then from there, we can use either point N or point K for a point slope form. We'll get there. So we have to find our slope first. of course, we must have our values again. So n was the value of, what would we say, 3, -2. And k is the value -1/2, comma 2. Slope is the rise over run. So it's y2 minus y1. In this case, y2 is going to be our n. So -2 minus 2 over 3 minus a -1/2, which will then turn to positives. We get -4 over 3.5. But if you have a calculator, you can just solve that pretty easily. But I'm going to leave it as a fraction instead. And I'm going to write -8 over 7. Okay. If you have any questions as to how I got -8 over 7, please ask me at an appropriate time. I can show you how we got that fraction. Again, you could just put it into a calculator and you'd be fine. But we found our slope. And here we decide, well, which angle or which point do I want to use? Do I want to use n? Do I want to use k? And personally speaking, I'm just going to use n. I think n is going to be easier. So for our point slope form, y minus y1 in this case, and it's not going to write for y1 here. Our y1 for n is going to be -2, but because we already have a negative, change that to a positive. Then we have our slope, -8 over 7. And then we have our x minus our x value from n. That's just 3. And that's it. That is our point slope. Of course, if you wanted your slope intercept, we had y equals -8 over 7 x plus 10 over 7. And that's perfectly good as well. Okay. So after we've done all that, we move on to the next example. Again, I recommend trying to do this on your own first. If you get stuck, revisit this video and move on from there. And so here, we're not working with median this time. We're actually working with altitude. Remind ourselves that this is going to be angle to opposite side, perpendicular segment. So we look at these two letters, O and R, determine which one is part of our triangle. O is part of our triangle. And what's the opposite side? Opposite side to O is going to be MN, which means we're looking at something on this line that's between M and N. Somewhere on that line exists a point called R. But in order for us to find the slope of the line of the altitude to OR, let's just draw a preliminary line. So we'll say that this is R. But because we know that this is R in quotations, we know that this line must be perpendicular. Oops. Oh man, wow. Okay, that's cool. Go ahead and just redraw that really quickly. I don't know what happened there. Gotta love technology. But we'll go ahead and draw that line, or that box right there, indicating 90 degrees. And remember, when we have a perpendicular angle on a coordinate grid, that means that these slopes are going to be opposite reciprocals of those two lines that are intersecting each other. So really, the first thing we have to do is find the slope of MN. So slope MN, right? Or rather, slope of MN, I should say, is we have to figure it out. So our rise from N to M is positive, so we'll keep it positive. So we're going 1, 2, 3, 4, 5 units up, and only 1 unit to the side, which means our slope of MN is going to be 5. But remember, our perpendicular slope is the opposite reciprocal of MN. So our perpendicular slope of OR, oops, actually these should have those lines here. The perpendicular slope is the opposite reciprocal of MN, which is 5. So opposite of positive will be negative. Reciprocal, flip the fraction, we will have a 1/5. And that is our slope for OR. And from here, this is actually going to be easier for us in the previous problem. In this equation with the line that contains the altitude OR, again, we have some imaginary line OR. We don't know where point R is on this line. And we're not even going to find it. We only need one point, and that point is going to be O. So O is -5, 1. And we're going to put this in our point slope form because we also have our slope. So our M is -1/5. So our point slope will be y minus y1, in this case it's just 1, equals our slope -1/5 times x minus, since we have a -5, double negative, change it to a positive. And that's our equation. That's it. That's our point slope formula. It's still an equation. Now, for those of us who like having our slope intercept form, you can solve for that. That's perfectly fine. Distribute the -1/5 over. You get y minus 1 equals -1/5 x minus 1. Then we add the 1 on both sides. And our formula, or equation rather, is going to be -1/5 x. And man, I'm really struggling today to write. Like so. And that's it. Again, either of those two answers are going to be acceptable. So if you have any questions, again, reach out to me at an appropriate time. Ask me anything you need as far as any of this work. But that's the end of this lesson. Next lesson will be on 6.7 and 6.8, but we're not going to cover that until next week. So stay tuned for that in case you miss it. Okay, I will see you all later. Bye-bye.